part 2 of the video on the Kepler's Law of Planetary Motion Lab. We are going to make the ellipses now that we have our points drawn, our 5, 8, and 2 centimeter pins. So, there's Bella again. Okay, all right. So what she's going to do now, she has her stuff here. What she's going to do is she's going to use this shoebox now or some type of cardboard. Again, if you have pieces of cardboard that you want to have like layers of, it's easier if you have more than one layer. So I moved this out of the way because I didn't want it to ruin the table. All right, so what she's going to do is she's going to start with one on the box and use the push pins. Or if you have some other tool, just be careful with what you're using. Yep, go ahead and push those in where those focal points are, which are the, one of those is the sun. All right, so that's perfect. So now what she needs to do, I have all these different strings. You can just make your own. Maybe it's bracelet stuff or yarn or string or something. I'm trying to think of other things you could use. And go ahead and use that. Might be scrap paper, t-shirts or something. All right, so now what she's going to do is she's going to find her string. Okay, go ahead and see if it fits around those 2 pins. Okay, it fits around good. Now, what you're going to do, Bella, is you're going to try to see if you keep, so just like this picture here. Here's the pencil. Just like the pictures there. She's going to try to make sure it doesn't go off the edges of the paper, and she's going to pull the string or the yarn tight and make her lips. So, see if it doesn't go off the edge, first of all, which means the sides, 2 sides is good. It's okay if it goes off top and bottom, but the 2 sides are good. All right, so what she's going to do, she's going to pull it as tight as she can, and it's okay if it goes off the paper. Just make sure you're not drawing on your table. And she's going to make her first 5 centimeter lips. It's okay. Go, yep, as tight as you can. Keep it tight. Okay. She got a little messed up there, huh? That's okay.
Messed up, sir.
It'll work as long as you think the sides are okay, because that's the real thing that we need to measure. The edge from this side to this side. That's the length of the major axis that we'll have to measure.
Looks like an egg.
Okay, so this is her okay first attempt there, so that's okay. She really just needs to make sure that these values are good, because besides this, we need to later on after we're done measure that. Okay. Now let's go ahead and take the pins off of there and the yarn off of there, and go ahead and move down to the 8 centimeter one. Now this one's a lot farther apart. You might have to get a bigger piece of yarn that you made. Okay, or she doubled up on the last one, so she's, oh, it goes off the edge, doesn't it? So we need to find one. This one might work too. Is this one small enough? Try that one.
Yeah.
Okay, so make sure it doesn't go off the edge on both sides. That side's good. Is that side good? Awesome. So make sure it doesn't go off the 2 pins. So she's going to make her second lips, make it taut or tight. And it's okay if it runs into the other one as long as you get the 2 edges of the lips good. Okay, good. A lot better. Good. Okay. All right, again, take that off and move it down to the next one. Okay. This is the 2 centimeter one, so you might have to get a smaller string. You can see if that one works, or you can get a smaller piece of string if you made a small version of it. Something that has to fit around those 2 pins. Good. Okay, pull it tight and make your ellipse. Good, that was a lot easier, wasn't it? Okay, awesome. Awesome job. Okay, all right, you take the pins off. We're done with the pins. Make sure you put it somewhere safe. You don't have it on the floor, so you step on it. Okay, all right, so now what we do, I guess we could take it off the box if you prefer, and we can use this little notepad thing here. Go ahead and move your paper over here. You're going to use your ruler, okay, and what you're going to do is I need you to measure the total length from edge to edge of the ellipse.
And centimeters are...
Centimeters, good, yes. In science, we use centimeters. We already use centimeters with the length in between the focal points, so we're going to use centimeters and estimate your best as far as that, as far as decimals.
3.5.
13.5, is it right on that line?
Yeah.
Okay. All right, so, yep, write down. Go ahead and maybe draw a length across, or however you want to do that, from edge to edge, and write that value down somewhere. Yep, you could have used the ruler there, so like this. So it does show, I'll show you on here when she's doing that. It does look like that. The length across is what you need. All right. Okay. So that's what that one looks like. Good. It says 13.5 centimeters. She can do the same thing with the second ellipse. Measure the total length across. Estimate what it is.
17.
Okay. Good so far. And she's going to do the next one. And then the last one, so that was 17. I I will make sure maybe to pick a picture of this and post this as well. What do you think?
10.3.
Okay. Because remember, each line in between the numbers of centimeters on here represents 1.1. So between your centimeters, you start at the line, depends on how your ruler is. So between 1 and 2, those all go like 1.1, 1.2. The middle one's 1.5, and then all the way to 1.9, then 2.0, okay? All right, so looks like the last one, please stop running, okay? The last one is 10.3 centimeters. So what we have, here's our data here that you need to have. The focal point of the first one's 5 centimeters, and then the length across is 13.5 centimeters. I'll make sure to take a picture of this too. The ellipse of 8 centimeters, its focal point is 17. And then the 2 centimeter one, the last one, the length across is 10.3 centimeters, okay? So that's the data there, and I will make sure, here, I'll make sure to take a picture now so I don't forget. Take a few so I have it. Oops, let me zoom out. Okay, so I have that. All right, so now it's time for the data table chart. Here, I'll turn it this way. The data table chart. So all she's gonna do, which I probably should have made a copy of this. Hopefully, none of the teachers have sent this out yet, but I'm going to go ahead and choose it centimeters. If you want to convert to millimeters, remember just move it one to the right. So instead of 5, you'd have 50. Instead of 13.5, you'd move it over and have 135. For 8, you'd move it over 1, you'd have 80. This one, you'd have 170, 20, and 10, 103. So if you want to write as millimeters, that's fine. Otherwise, you can leave it as centimeters. So again, we have 5 centimeters, and that was 13.5. I'll make sure I send this to you as well. Oops. And then this one was 8. That one was 17, correct, Bella? Okay, and this bottom one, centimeters. And that was that, Bella? 10.3? Okay, so there's our values of the top, middle, and bottom ellipse. And there's our values there. And like I said before, eccentricity is taking this first value. And if you want to use it as 50 millimeters and 135 millimeters, you can use that. It's okay if you don't convert. I understand, since I'm not in class with you. So for example, on this first one, I would just take 5 centimeters divided by 13.5 centimeters. Okay, and I would get that value. And then when you're done with that, then you're going to explain which one's least round, most round. Remember, the closer to 0 it is, the more round it is. The farther away from 0, closer to 1, it's going to be more eccentric and more round, or sorry, least round. All right, so with these here, this is the elliptical path that the planets go around, okay? That's the path they go around, and one of these is the sun. Sorry, one of these is the sun. All right. So this is Newton's first, I apologize, Kepler's first law. And so you're going to determine the eccentricity of each of those. And then you'll look at the planet table on the other page like I talked about, and you'll go and answer the question. And they're going to explain, was your prediction correct or not? Was, maybe you picked the bottom one as being the most eccentric or flattest ellipse. You need to explain why that is. So if you look at the data here, okay, if you look at the data here, what does it show? Which one's the flattest ellipse? What do you think, Bella? Which one's the flattest or most eccentric ellipse?
Me.
Okay, the top, the middle, or the bottom one is the flattest?
Middle.
Okay, yes, the middle ends up being the flattest, or should be the flattest. If you see it, it has the bigger length across. If you divide those, it should have the biggest number. Okay, so you have to see if that holds true with the math. Okay, all right, so if there are any questions, you had to be through the background and through, and I'll send a data table and the picture of the ones we made, and you have to be through number 8 for today. Okay, thank you. If you have any questions, email me.
Email me.